Today's question is dy by dx equal to square root of y raised to the power of 4 minus y raised to the power of 2 over x raised to the power of 4 minus x raised to the power of 2. Here x is greater than 0 and y is greater than 0. When you substitute y as 2 over root 3 and x as 2, then we need to give the answer in the form of y equal to 2x over f of x. So this is the 15 marks question. This question is taken from the Cambridge IGCSE. Let's see how to solve it. So in the numerator we have y raised to the power of 4 minus y raised to the power of 2. So this y raised to the power of 4 also we can write in terms of 2, that is 2 plus 2, isn't it? So let's write 4 in terms of 2 plus 2. Now this y raised to the power of 2 plus 2, it is in the form of a raised to the power of m plus n. So we can write this as a raised to the power of m times a raised to the power of n. Same like that, y raised to the power of 2 plus 2, we can write it as y raised to the power of 2 times y raised to the power of 2 minus y raised to the power of 2. So here and here we have y raised to the power of 2 as a common. So let's take it as common. Then we left y raised to the power of 2 minus 1. So this is the numerator. Same like that we do for the denominator also. Denominator also we have x raised to the power of 4 minus x raised to the power of 2. Here x raised to the power of 4 we can write in terms of 2, that is 2 plus 2. We can write x raised to the power of 2 plus 2 as x raised to the power of 2 times x raised to the power of 2, and still we have minus x raised to the power of 2. So here x raised to the power of 2, take it as common. So then you will left x raised to the power of 2 minus 1. So the denominator also it turns into x raised to the power of 2 times x raised to the power of 2 minus 1. Now observe only the numerator. Numerator we have in the form of square root of ab. So we can write this as square root of a times square root of b. So same like that we can write this is a and this is b. So we can write this as square root of y raised to the power of 2 and then square root of y raised to the power of 2 minus 1. Same like that denominator also we can write this as x square root of x raised to the power of 2 times square root of x raised to the power of 2 minus 1. Here square and square root gets cancelled and here square and square root gets cancelled. So we left only y at the numerator and x at the denominator. So here y and here x. So this is the dy over dx. Now what we do? Separate the individual terms. Y variables are in one side and x variables are in another side. Now let's integrate both of the expressions. Integral 1 times square root of y square minus 1 dy. The formula is ln of y plus square root of y square minus 1, isn't it? So that is equal to 1 over x square root of x square minus 1 dx. The formula is ln of x plus square root of x square minus 1 plus some constant c. This is the easiest formula, but we need to show our answer in terms of y equal to 2x over 5 of x. If you take in terms of log, then it is difficult to show in that form. First I will show you why it is difficult. Then I will show you what is the correct formula, easy to solve for our result. So what's the given question? When you substitute y equal to 2 over root 3 and x equal to, we need to give your answer in terms of this. So let's substitute y as 2 over root 3 and x as 2. So ln of y value is 2 over root 3 plus square root of y value is 2 over root 3 whole square. If you do whole square, then become 2 square is 4, the numerator is 4, the denominator is root 3 whole square, which is 3 only. So it becomes 4 over 3 minus 1. If you take LCM here, the LCM is 3, so the 4 minus 3, which gives 1 over 3. So after simplify, then you will get it is 1 over 3 only. This square root of 1 over 3, we can write this as square root of 1 over square root of 3, isn't it? Square root of 1 is nothing but 1 only. So that means we can write this as 1 over root 3. So let's write square root of 1 over 3, that is 1 over root 3. So after taking the LCM root 3, then you will get 3 over root 3. So left hand side turns into ln of 3 over root 3. That is equal to ln of, so let's substitute x as 2. So x is 2 plus square root of x square, that is 2 square, which is 4 minus 1, which gives 3. So root 3. So let's write root 3 plus c. In the left hand side we have ln of 3 over root 3. Here if you multiply root 3 over root 3, then denominator root 3 times root 3, which gives only 3. So let's write only 3 here. then this 3 and this 3 gets cancelled, so we left only root 3. So the left hand side turns into ln root 3, that is equal to ln 2 plus root 3 plus c. This is a ln term and this is ln term. Let's take it in one side. So if you take it left hand side, it become minus, so that is equal to your constant. Now the left hand side, it is in the form of ln of a minus ln of b. In subtraction form, we can write this as ln of a over b, isn't it? So we can write this as ln root 3 over 2 plus root 3, that is equal to c. That means the constant value is ln of root 3 over 2 plus root 3. Instead of c, we need to substitute ln of root 3 over 2 plus root 3. Now observe the right hand side. We have ln of some a plus ln of b. It is a plus term. Ln of a plus ln of b. When we have in addition term, we can write this as a product term, ln of ab, isn't it? So use that property here. We can write this as ln of x plus square root of x square minus 1 times root 3 over 2 plus root 3. So here we have a ln term and here we have a ln term. Let's take antilog on both sides to get rid of this ln. So then we left only this y and x terms. But here we have a square root term and here we have a square root term. So it is difficult to simplify this long expression. That's why we should not take in terms of this ln of y plus square root of y square minus 1 and ln of x plus square root of x square minus 1. So that's what I said. This formula is not suitable for this question. So instead of taking this, we need to think another one. Observe here we have a y and square root of y square minus 1. So let's recall one of the most useful identity, that is 1 plus tan square theta, that is equal to secant square theta. From here we can find tan square theta, isn't it? So tan square theta equal to secant square theta minus 1. Here we have a square. So if you take square root on both sides, then you will get tan theta equal to square root of secant square theta minus 1. Now observe here we have a y square minus 1 and here we have a secant square theta minus 1. So let us consider y as secant theta. Then square root of y square minus 1, that is square root of secant square theta minus 1, that is tan theta. So we can write, so square root of y square minus 1, it turns into tan theta. If you y consider as secant theta, then dy is secant theta tan theta, isn't it? D theta. So let's substitute these values in this left hand side. Now we have integral 1 over y is secant theta, so let's write secant theta. Then square root of y square minus 1, which is tan theta, so let's write only tan theta, times dy. Dy is secant theta times tan theta d theta. So let's write that. Observe here we have a secant theta tan theta and in denominator also we have secant theta tan theta. So let's get cancel these two terms. So we left only integral of d theta, which is only theta as some constant, isn't it? So we consider y as secant theta. From here we can take theta as secant inverse of y. So instead of theta, I'm going to write secant inverse of y. After doing this integral of left hand side, we got this. We got secant inverse of y. So that is equal to, so now observe the right hand side. Right hand side also, what we have integral 1 over x square root of x square minus 1 dx. Now you consider x as secant theta. Then square root of x square minus 1, it turns into tan theta. Then dx is turns into secant theta tan theta d theta. So after substituting here, so we got only theta plus some constant, isn't it? Just like before we did with the variable y. From here theta is secant inverse of x. So let's take right hand side also. Integral of 1 over x square root of x square minus 1 dx. We can write this as secant inverse of x plus some constant. We don't know that constant, we need to find out that constant. From here we can write y equal to secant of secant inverse of x plus c, isn't it? We can write secant inverse of x, that is equal to y equal to secant of this right hand side term. Now observe here, it is in the form of secant of a plus b. This is our a and this is our b. So to find this, first we need to find c value. We need to substitute y and x values in this expression 1. So let's take the expression 1. What we have, secant inverse of y, that is equal to secant inverse of x plus some constant. And what we given 2 as 2 over root 3 and x as 2. Let's substitute here. Secant inverse of 2 over root 3, that is equal to secant inverse of 2 plus some constant. What is sine 0? Sine 0 is 0. Cos value is 1. That means secant 0 is 1 over 1. So it's nothing but only 1. We know that secant theta is nothing but 1 over cos theta. So secant 30, that secant 30 is 1 over root 3 by 2. It's nothing but 2 over root 3. Then secant 60 is only 2. Then secant 90 is 1 over 0 is nothing but infinity. So these are the values of secant. So now here we have a secant inverse of 2 over root 3. So when we get 2 over root 3, secant 30, secant pi over 6 is 2 over root 3. So let's take that. So secant inverse of secant pi over 6, the value is 2 over root 3. So instead of 2 over root 3, I am writing secant pi over 6. So that is equal to secant inverse of what we have? We have 2. So when we are getting 2, we are getting secant 60 is, that is secant pi over 3 is 2. So let's write secant pi over 3 plus some constant. Here this secant and secant inverse are gets cancelled. So we left only the radians, pi over 6, that is equal to pi over 3 plus some constant. From here we can find the c value. So after taking the LCM 6, then we will get pi minus 2 pi, which gives numerator it become minus pi. So the constant term is minus pi over 6. So let's substitute back. Here the c value is minus pi over 6. Let's substitute here. So that means our y is in terms of secant of a minus b form. So we need to recall secant of a minus b formula. Secant of a times secant of b over 1 plus tan a tan b. This is the formula for that. So y equal to secant of, this is a, that means secant of x. After gets these two cancel, we left only x. So let's simply write x now. So secant a turns into x times secant of b, that means secant of pi over 6. What is the value of secant of pi over 6? That is 2 over root 3. So let's write 2 over root 3 over 1 plus tan a, that means tan a is nothing but secant inverse of x. At starting we consider x as secant theta, isn't it? 1 plus tan square theta, that is equal to secant square theta. From here we found that tan theta is square root of secant square theta minus 1, isn't it? So square root of x square minus 1, that is tan theta. So we consider x as secant theta. So from here we can write this as theta is secant inverse of x, isn't it? So this theta you need to substitute here. So tan of, instead of the theta, I am going to substitute secant inverse of x. So tan of secant inverse of x, that is equal to square root of x square minus 1. So this value is square root of x square minus 1. So let's take that. Square root of x square minus 1. Tan b. Tan b is tan pi over 6. That means tan 30. Tan 30 is sin 30 over cos 30. So what is sin 30? Sin 30 is 1 over 2 over cos 30 is root 3 over 2. So that means tan theta is 1 over root 3. So let's write 1 over root 3 here. So that is equal to 2x over root 3. This is the numerator term. Now we need to check the denominator. What we have? 1 plus, here square root of x square minus 1 over square root of 3. After taking the LCM, so then you will get root 3 plus square root of x square minus 1 over root 3. Here root 3 and here root 3 gets cancelled. So we left only 2x over, it is in terms of x only. So this is f of x. And we showed that y is in terms of 2x over f of x. If you like this content, subscribe to my channel. Thank you for watching.